This is SpaceTime, Series 23, Episode 14. Coming up on SpaceTime, discovery of a new type of aurora, a rare Atiras asteroid discovered inside the orbit of Venus, and NASA's new Orion manned spacecraft, destined for the Artemis 1 mission beyond the Moon, undergoing testing. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new type of aurora, dubbed the dunes, has been discovered in the skies above Finland. A report in the journal AGU Advances claims the unique features of the dunes are helping scientists better understand a mysterious layer of Earth's atmosphere. Aurorae are nighttime light displays in the atmosphere near the Earth's poles. They occur when high-energy charged particles, usually protons and electrons, generated by geomagnetic storms from the Sun, collide with the Earth's magnetosphere and are then guided by the planet's magnetic fields through the ionosphere, a region of charged particles. As these particles travel down towards the north and south magnetic poles, they collide with oxygen and nitrogen atoms and molecules in the Earth's upper atmosphere, causing them to excite and emit photons, giving off a glow and producing colourful curtain-like displays, known as the northern and southern lights, the aurora borealis and aurora australis. The colours being emitted depends on the particles being ionised. Reddish-brown glows are caused by the collision of particles with single oxygen atoms in the Earth's upper atmosphere, usually above 300 kilometres. Lower down are green hues created by single oxygen atoms down to altitudes of around 100 kilometres. The kaleidoscope turns a whitish-yellow beige when nitrogen's mixed in with the oxygen. Aurorae can also exhibit blue, red or even purple glow in the lower atmosphere, caused by the excitation of molecular nitrogen below 100 kilometres. But unlike most aurora lights, which are oriented vertically like curtains, the dunes appear as thin ribbons of green lights arranged horizontally, sort of like fingers reaching towards the equator for hundreds of kilometres. The dunes were discovered by amateur auroral photographers in Finland in 2018. The study's lead author, Minna Palmroth from the University of Helsinki, suspects the dunes are visible manifestations of undulations of the air known as atmospheric waves. Atmospheric waves are undulations of air caused by the atmosphere having regions of different temperatures and density. Now, if correct, this would be the first time scientists have actually been able to observe atmospheric waves through the aurora. Based on the images, the authors think the dunes appear in a thin layer around 100 kilometres above sea level. And knowing the altitude of the dunes helps the researchers to determine the physics behind them. This is a region that's always been difficult to study because it's too high for balloons and too low for satellites. The atmosphere at this altitude, between around 80 and 120 kilometres, is sensitive to changes in energy both from the Sun and from Earth's lower atmosphere. And the energy fluctuations in this region can indirectly affect the trajectories of spacecraft. Palmroth and colleagues suspected the dunes are visible manifestations of a kind of atmospheric wave called a mesospheric bore. Mesospheric bores are waves that propagate through the atmosphere, like ripples spreading across a pool, creating curls and folds that bend horizontally and spread out over long distances. By studying these dunes, physicists can better understand these types of waves and the parts of Earth's upper atmosphere where they occur. You're listening to SpaceTime. Still to come, a rare Atiras asteroid discovered, and the crew of the International Space Station successfully complete refurbishment work on the Alpha Magnetic Spectrometer. All that and much more still to come on SpaceTime. Astronomers have discovered a rare asteroid orbiting the Sun inside the orbit of Venus. The asteroid, catalogued as 2020 AV2, belongs to a small class of space rocks known as Atiras, which have orbits that fall within the orbit of the Earth. The tiny body was discovered by Caltech's Vicky Transient Facility at the Mount Palomar Observatory. It's the third Atira discovered by Vicky, which is especially adept at finding these asteroids because it rapidly scans the entire sky trying to catch sight of them. Atiras are especially hard to spot because of their close orbits to the Sun, making them visible only at dusk and dawn. Astronomers are now trying to get follow-up observations of the asteroid to better pin down its size and unusual orbit. Best estimates suggest 2020 AV2 is between 1 and 3 kilometres wide and has a 151 Earth-day orbit always interior of Venus and with its closest approach to the Sun bringing it close to the orbit of Mercury. Astronomers think the asteroid probably migrated to its current orbit from further out in the solar system. And unless it's flung out of its current orbit through some gravitational encounter with Venus or Mercury, it'll probably end up crashing into one of these two planets. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Let's talk about this asteroid that's been found closer to the Sun than Venus, which sounds, that sounds normal for some of the time, but this is all of the time from what I'm understanding.
Indeed, that's absolutely right. It is a bit surprising. When I was a lad, 187 years ago, the asteroids all stayed, they were terribly well behaved. They all stayed between the orbits of Mars and Jupiter. We knew of really very few that strayed outside that range. But of course, as time has gone on, we've discovered more and more and more asteroids. And there is now a class of asteroids which are called Atiras. And I think they're named after the sort of prototype of the class, which is probably called Atira. And Atiras are asteroids that orbit, whose orbits are wholly within the orbit of the Earth. So it's not a very common place to be. We know of many asteroids whose orbits cross the orbit of Earth, but Atiras have orbits that are entirely inside the orbit of Earth, so they always are nearer to the Sun than the Earth is. But there's only 21 of them. They're not numerous objects. And so it's perhaps surprising that we found an even more extreme example of these, and it was found this year. In fact, the observations were made on the 4th of January at a place that in its own strange way is close to my heart, because it's what used to be called the Palomar-Schmidt telescope. It's now basically called the ZTF, which is the Zwicky Transients Factory.
And for all you Americans, it's the ZTF.
I'm sorry, I'm so sorry for that.
We've got to speak the universal language here, Fred.
We have indeed, yes, that's right. So a few subtleties about this. Well, the telescope itself, the reason why I'm very fond of it is that it is the twin, effectively, of the United Kingdom Schmidt telescope, which is at Siding Spring Observatory, and which is actually what brought me to live in Australia in the first place 100 years ago. The Caltech machine, though, the ZTF, named after Fritz Zwicky, of course, the great astronomer in the 1920s and 30s, actually the discoverer of dark matter, but that's another story. The telescope is a 1.2 metre or 48-inch Schmidt telescope, and it was the basis of that Palomar-Schmidt, or sometimes called the Ocean Schmidt now because it was renamed a few years ago, and is now the Zwicky Transient Facility. Our Schmidt telescope was essentially modelled on that one, also with a 1.2 metre diameter corrector. So these telescopes are wide-angle telescopes. They were built for photography. Our telescope now does something quite different. It will soon when the commissioning work is finished on our new Starbugs instrument. It uses fibre optics to look at many objects at a time, whereas the Caltech one at Mount Palomar actually has a wide-angle electronic camera, and that is really why it can be used for looking for objects that change in space. And by change, I mean they either get brighter or dimmer, or they move. Of course, this thing moves. That's how you find asteroids. You look at them at 1 minute and look at them a few minutes or a few hours later, and they've moved in space, and that tells you that it's a relatively nearby object. Now, that discovery, though, is unusual because if you think about the orbit of an object that lies within the Earth's orbit, you're only going to see it soon after sunset or shortly before sunrise, because the object's always going to be close to the sun in the sky. And that is even more extreme in this case, because the object, which I'll tell you its name, 2020 AV2, it actually, as you said right at the beginning, it keeps its orbit entirely within the orbit of Venus, not just inside the Earth's orbit, but inside the orbit of Venus. And of course, because it's inside the Earth's orbit, it means it's an Atira asteroid. As I mentioned, they're ones whose orbits are always within the Earth's. But people are now calling this a Vatira because it's within the orbit of Venus, and it is the first one that has been discovered.
Well, how dare we just assume that everything associates with Earth? I mean,
exactly.
The Venusians must be getting pretty steamed.
Yeah, they must be. And actually...
Well, they are actually getting quite steamed.
Well, they're steamy all the time. That's right. It's a horrible place. The sulfuric acid drizzle and all the rest of it. It makes you wonder, though, whether we'll find ones inside the orbit of Mercury, which might be called Atiras asteroids. Anyway, 2020 AV2, the first Venus or internal to Venus asteroid, is only no more than 3 kilometres across. Its orbit is quite elongated, and in fact, when it's at its closest to the Sun, it's not far from the orbit of Mercury. So you can bet your life we'll find asteroids eventually which are within the orbit of Mercury. So how did it get there? And, well, one of the professors of physics at California Institute of Technology, who's actually co-investigator on the Zwicky transient factory, he says an encounter with a planet probably flung the asteroid into Venus's orbit. It's the opposite of what happens when a space mission swings by a planet for a gravity boost. Instead of gaining energy from a planet, it loses it. And there is another comment as well.
So more or less gets stuck. It was on its way somewhere and got distracted by
that's right.
a pretty girl, and that was that.
More likely the gravitational pull of maybe Mars, maybe Jupiter. It depends on where it started its journey.
So it's got a big D-cell.
Yeah. The only pretty girl in the solar system is Venus, which is the only female planet. So
Like what I said.
Yeah, that's right. So it could have been Venus as well. Another of the colleagues of Tom Prince at Caltech, George Helou, I think is how you pronounce it. Helou. It could be hell yeah, not hello. He said, getting past the orbit of Venus must have been challenging. The only way it will ever get out of its orbit is if it gets flung out via a gravitational encounter with Mercury or Venus. But more likely, it will end up crashing on one of those two planets. That's a really interesting prognosis for this little world that until the beginning of this year we didn't know about.
I suppose we shouldn't be too surprised because there are things coming and going all the time, and there are a lot of various forces acting upon and against each other from time to time. It stands to reason that you're not going to just find asteroids in the outer reaches. Here we are with 21 of them that are just sort of flinging themselves around inside Earth's orbit going, oh, this is nice. I could stay here. Or whatever they want to do, really. But it's all subject to the forces of gravity.
Exactly. What I think is the really interesting aspect of this is that people will, of course, encouraged by this discovery, look for more, because we don't know whether there are more of these internal to Venus orbit asteroids or whether 2020 AV2 is unique. But notwithstanding the Zwicky transient factory, the ZTF, there is a new facility which will come online. I think it actually is later this year. It's been in construction for a good while, maybe 10 years or so. I saw it last year on top of its mountain in northern Chile. It's, until very recently, it was called the LSST, which is the Large Synoptic Survey Telescope. This is an 8-meter class telescope which will survey the entire southern sky every week, effectively, every 6 nights.
Wow. That's impressive.
That's right. And that will be turning up objects, small objects in the solar system like you've never heard before. What was being called the Large Synoptic Survey Telescope has been renamed. It has a formal name, which I'm absolutely delighted with because it commemorates one of the greatest women in astronomy, Vera Rubin. So it will be called the Vera Rubin Observatory when it comes online. And that's a great name.
It is.
Vera, of course, also the person who put dark matter on the map back in the 1970s.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Astronauts aboard the International Space Station have successfully completed a 4th spacewalk designed to refurbish the Alpha Magnetic Spectrometer. The spectrometer was the last major science instrument brought up to the orbiting outpost by the Space Shuttle before its retirement, flying up on Endeavour on STS-134. It's attached to the port truss on the outside of the space station, where it's designed to detect high-energy cosmic rays, ionized high-speed particles, mostly protons, electrons, and helium nuclei. These are generated to near luminal speeds by things like supernovae and black holes. The data coming from the spectrometer has provided a wealth of information for scientists researching fundamental questions about the nature of antimatter and mysterious dark matter. However, the unit was only ever designed to operate for around 5 years, and it was never designed to be serviced in space. The problem is, the data that it's been providing is so valuable, scientists decided it's worth at least trying to design a way to refurbish it and keep it operational. And eventually, after a lot of head-scratching, they came up with a plan. It involved 4 extravehicular activities, or EVAs. That's NASA speak for spacewalks. The first of these EVAs saw astronauts set up equipment, handrails and tools specially designed for the job. They then removed the spectrometer's protective debris shielding and a vertical support beam, and cut away the multi-layer insulation covers that encase the cooling system's pipes. The second EVA saw the removal of a cable bundle inside the spectrometer, capping the remaining wires and then attaching 2 new power cables. Spacewalkers then began venting and depressurizing the cooling system, before cutting away more multi-layer insulation and then cutting through 8 stainless steel coolant pipes. The third EVA saw the cutting and splicing of the 8 coolant pipes to allow the installation of a new pump and its associated cables to power the spectrometer's tracker cooling system. Finally, the just-completed 6-hour and 16-minute 4th spacewalk saw astronauts replace the multi-layer insulation, carry out leak checks to the cooling system, and open a valve to pressurize the system. However, it didn't go smoothly, with one of the coolant lines beginning to leak, forcing astronauts to install a jumper to fix the problem. Ground teams then began sending commands to the spectrometer to fill the new thermal control system with carbon dioxide. They're now allowing the system to stabilize and power up the pumps in order to fine-tune performance. These upgrades are designed to keep the Alpha Magnetic Spectrometer going for the remainder of the space station's life, which will last until at least 2024. You're listening to SpaceTime. Still to come, the Orion Spacecraft under test, and we check out the February night skies on Skywatch. All that and more still to come on SpaceTime. Well, with all the fuss in recent months over NASA's program to use SpaceX Dragon capsules as well as Boeing's Starliner spacecraft to transport crew to and from the International Space Station, attention has moved away from NASA's other manned space program, Artemis, which will use the Orion capsule. Orion will launch aboard NASA's new heavy lift rocket, the SLS, flying crew on deep space missions to the Moon, Mars and beyond. The spacecraft uses the same basic configuration as the Apollo Command and Service Module, which took astronauts to the Moon in the 1960s and 70s. But it's much larger in size, with updated thermal protection systems and, of course, 21st century technologies, such as advanced avionics and control systems, better life support systems, and new, faster computers with far greater capacity. Remember, the computers on Apollo had less power than a digital watch. Like Apollo, you can split the Orion spacecraft into 2 segments. There's a crew module and a service module, the crew module being the only one that returns to Earth after a mission. The 10,400 kilogram crew modules are built by Lockheed Martin and can support up to 6 crew members for 21 days. It uses glass cockpit interfaces modelled after those used on the Boeing 787 Dreamliner, an automated docking system, improved waste management systems for the crew, and it has a parachute system based on that used on Apollo and the Space Shuttle's solid rocket boosters. The crew module will be shrouded in a fiberglass boost protective cover to protect it from aerodynamic and impact stresses during the ascent phase of the mission. In the event of an emergency, either on the launch pad or during ascent, a launch abort system will separate the crew module from the rest of the launch vehicle using 3 solid rocket motors, an abort motor, an attitude control motor, and a jettison motor. The crew module is designed to be reused multiple times, and it can be upgraded as new technologies are developed or as mission parameters change. Attached to the crew module is the 15,461 kilogram service module. It contains the spacecraft's main engine, solar arrays to power its systems, auxiliary equipment, and the crew's oxygen and water supplies. It's built by Airbus Defence and Space, and is based on the European Space Agency's Automated Transfer Vehicle, the ATV, which was used for many years to ferry cargo to the space station. The spacecraft's propulsion comes from a single Aerojet Rocketdyne hypergolic AJ-10 main engine, while 8 R4D-11 engines and 6 pods of custom reaction control systems developed by Airbus will provide the spacecraft's secondary propulsion. Orion's first unmanned test flight launched aboard a Delta IV Heavy rocket on December 5, 2014. The successful flight lasted 4 hours and 24 minutes, splashing down on target in the Pacific Ocean. Orion's next flight will involve another unmanned test flight, this time mated to the SLS. That's slated for next year on the Artemis 1 mission, which will travel beyond the Moon and back. Then in 2022, the Orion Artemis 2 mission will launch aboard another SLS rocket, and this will be its first manned mission, which will orbit the Moon. That will be followed in 2024 by the Artemis 3 mission, which will transport astronauts to the first modules of the Lunar Gateway space station, which will be in orbit between the Earth and the Moon. There they'll transfer to a lunar lander, which will then carry them down to the lunar surface. The first time humans have walked on the Moon since 1972. The Orion spacecraft destined for the Artemis 1 mission is now undergoing trials at NASA's Plum Brook test facility in Ohio. The European Space Agency Service Module Test Campaign Manager Pierre Borisvet says Orion will be subjected to temperatures ranging from 75 to minus 115 degrees Celsius in a vacuum for more than 2 months, the same temperatures it will experience in direct sunlight or shadow while flying in space. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian-Gregorian calendars, and of course it's the shortest month of the year, the only one to have a length of less than 30 days. The month has 28 days in common years and 29 days in leap years, with the quadrennial 29th day being called a leap day. The additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. See, because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year would drift over time with respect to the event that the year was supposed to track. So, by inserting an additional day every fourth year, that drift can be corrected for. These extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Throughout most of the month, skywatchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as 2 separate streams, although they rarely produce more than 1 or 2 meteors per hour. They're peaking about now, and the best time to see them is to look east just a few hours before dawn. Looking north and high in the sky this time of year is the famous constellation Orion the Hunter. Orion's one of the best known and most recognizable constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon. Orion was a mighty but very egotistical and conceited hunter who boasted that he could kill all the animals in the world. Not too impressed by this claim, the earth goddess Gaia sent Scorpius the Scorpion to kill him and to save the animals. Orion was stung in the shoulder, but the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the Scorpion were placed in the heavens to play out the story each year, with the Scorpius rising in the east as the defeated Orion sets in the west. A variation of this fable speaks of Orion getting a bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship, and he tricked Artemis into testing her skill by shooting an arrow at a distant speck in the ocean. Now, Artemis didn't know it, but that speck was actually Orion swimming to escape a giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body into the sky as the stars we see today. Variations of the story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, god of the underworld and of regeneration. The earliest depiction that has been linked to the constellation of Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated it to have been carved somewhere between 32 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including the ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identifiable by its rectangle of 4 stars surrounding a central trio of stars in a row which form Orion's belt. And hanging from the belt are the stars which make up Orion's sword. Now, to those in the southern hemisphere, Orion appears upside down, with the sword of his belt pointing upwards. Now, if you look carefully at the sword, you'll notice the middle star looks rather fuzzy. And that's because it isn't a star. Rather, it's a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, it's the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is over 24 light-years wide and contains as much mass as 2,000 stars. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. In fact, the nebula has revealed much about the process of how stars and planetary systems are formed out of collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of massive nearby stars on the nebula. The brightest star in Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion's sting on Orion's shoulder or armpit. Located some 643 light-years away, Betelgeuse used to be the 9th brightest star in the night sky, but it's faded dramatically in recent months. Astronomers still aren't sure why. Betelgeuse began its life about 10 million years ago as a blue giant. Calculations of its mass range from slightly under 10 to slightly over 20 times that of the Sun. And at its most luminous, it was some 100,000 times brighter than the Sun. Betelgeuse is so big that if it were placed where the Sun is at the centre of our solar system, its surface would extend almost as far out as Jupiter, completely engulfing the orbits of Mercury, Venus, Earth, Mars, and the main asteroid belt. It's expected to explode as a core collapse or Type II supernova any day now, which in astronomical terms could mean tomorrow, or it could be a million years from now. When it does explode, it'll temporarily outshine all the other stars in the galaxy, and it will be clearly visible in the daylight sky from Earth. Oh, and that name Betelgeuse? Well, you may have heard it described by a different name, Betelgeuse. But both Betelgeuse and Betelgeuse are simply tortured mispronunciations of its original Arabic name, Ibtal Yaza, meaning the hand of the big man. The big man, of course, being Orion the Hunter. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star Rigel A is some 863 light-years away, with about 23 times the mass of the Sun. The star has exhausted its core hydrogen supply. It's moved off the main sequence and swollen out to between 79 and 115 times the Sun's radius, and somewhere between 120,000 and 179,000 times its luminosity. It's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. As that happens, the core will collapse down on itself, becoming a super-dense object known as a neutron star. Rigel pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars, which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to the beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods of several days to a few weeks. Its companion star Rigel B is about 500 times fainter than the supergiant Rigel A, and it can only be seen in a telescope. Rigel B itself is what's called a spectroscopic binary, comprising 2 main sequence blue-white stars. Spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated from our viewpoint here on Earth by their spectroscopic signatures. The 2 stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. One of these stars, Rigel BB, may itself be a binary. Rigel B also appears to have a very close visual companion, Rigel C, of almost identical appearance. The next brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 20 million years. That's old enough for a star of this mass to have consumed most of the hydrogen in its core and begin evolving away from the main sequence into a blue giant. Astronomers describe stars in terms of spectral types. That's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. That's followed by spectral type B blue stars, only slightly cooler and less massive. Next on the list are spectral type A white stars, followed by spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun is, spectral type K orange stars, and the coolest and least massive of all are known as spectral type M red stars. Now, each spectral classification can also be subdivided using a numerical digit to represent temperature, with 0 being the hottest and 9 being the coolest. And you can add a Roman numeral to that to represent luminosity. Now put all that together and our Sun is officially classified as a spectral type G2V yellow dwarf star. Also included in the stellar spectral classification system are types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit in a category between the largest known planets, which are about 13 times the mass of Jupiter, and the smallest known spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. The Orion Nebula contains a very young open cluster known as the trapezium, due to its astrum of 4 primary stars. The trapezium is a component of the much larger Orion Nebula cluster, an association of some 2,800 stars with a diameter of around 20 light-years. But surely one of the most stunning nebulae within the Orion constellation is the spectacular Horsehead Nebula Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east in Orion's belt and part of the much larger Orion Molecular Cloud Complex. Located 1,500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most easily identifiable nebulae because of the shape of its swirling cloud of dark dust and gases, which bears a striking resemblance to a horse's head. To the west of Orion's belt is a V-shaped grouping of stars, which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V also forms part of a large open cluster of stars known as the Hyades. One of Taurus's eyes is a giant spectral type K orange star called Aldebaran, or the Follower, which is located about 65 light-years away and is about 1.5 times the mass of the Sun. Aldebaran has evolved off the main sequence, having exhausted the hydrogen at its core. And the collapse of the centre of the star into a degenerate helium core has ignited a shell of hydrogen outside the core. Aldebaran is thought to contain a number of Jupiter-sized planets. It follows the Pleiades or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located within the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 433 light-years away. Greek mythology tells us Orion fell in love with the Seven Sisters and pursued them for a long time. But eventually Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert near the Aldea region in outback South Australia. There, Orion is a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. The Dreamtime story has Orion's right hand holding a club filled with magic fire, which is represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hyades star cluster, taunts Orion standing in front of him. It says she defensively lifts her foot, represented by the star Aldebaran, which is also filled with magic fire. And this causes Orion great humiliation, putting out his fire and allowing the Seven Sisters to escape. One of the interesting facets about this ancient story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a period of about 400 days. In fact, it's speculated that its current dimness may be due to an unusually deep fading due to this variability. Interestingly, this idea that the Pleiades represent 7 sisters is remarkably similar in legends all over the world, from cultures which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the Seven Sisters nickname. But if you check it out with a telescope, you'll see this spectacular open star cluster actually consists of more than 100 stars. Okay, let's follow Orion's belt to the east, and that brings you to Sirius, not just one of the nearest, but also the brightest star in the night sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. But to the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as the lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motions across the sky. Looking high in the southern sky in February, you'll see the second brightest star in the night sky, Canopus, a white supergiant, located 313 light-years away. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin known as the poop deck, which is represented by the constellation Puppis. Also looking spectacular in the southern skies this time of the year are the Large and Small Magellanic Clouds, two dwarf galaxies which are satellites of our own galaxy, the Milky Way. The Magellanic Clouds were known to Polynesian and Maori and served as important navigation markers. They were named after the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Sadly, Magellan himself never completed the voyage, being killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead, about 168,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers classify it as a disrupted barred spiral. It's about 14,000 light-years in diameter and contains around 10 billion times the mass of our Sun. The Small Magellanic Cloud is slightly lower and to the west, and it's located about 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide and with about 7 billion times the mass of our Sun. Astronomers speculate that it too may once have been a barred spiral galaxy, but it became disrupted thanks to the gravitational tidal perturbations of our own galaxy, the Milky Way. Joining us now is Jonathan Nally, the editor of Australian Sky and Telescope magazine, to take us for the rest of our tour through the February night skies.
G'day, Stuart. Yeah, well, it's February, so it's still the height of summer here in the Antipodes. That means it's great stargazing weather, of course, lots of nice warm nights, clear skies, and lots of great constellations and other things to see up in the sky as well this time of year. So at this time of year in the evening, when most people would be out doing their stargazing, you've got the Milky Way just stretching right across the sky from north to south, or south to north, whichever way you want to go. You really can't miss it, and the darker your skies, of course, the more apparent the Milky Way is, because the Milky Way is just our galaxy seen from the inside, and they call it Milky because there are thousands of stars, or 100 millions of stars in the Milky Way, but most of them are so faint that we can't discern them with the naked eye. They just sort of all blend together, and you've got this sort of milky sort of patch all the way across the night sky. So really looks good if you get to a dark spot and have a good look at it away from street lights and things. And along the Milky Way, that's where you find all the really good constellations with the bright stars and the good deep sky objects, star clusters and colourful nebulae, that sort of thing. Because looking into the Milky Way, we're looking through more density of stars and stuff rather than sort of looking at 90 degrees above or below the plane of our galaxy and looking into more sort of empty space. So anyway, starting right down in the south, right down the bottom part of the Milky Way as it is at the moment, we have the Southern Cross, of course, always down there, and above it are three constellations. It used to be one constellation before it was split up. It used to be called Argo Navis, the ship of the Argonauts of mythological fame.
This is Jason and the Argonauts and their search for the Golden Fleece we're talking about.
That's right, yep, that old mythology. And the constellation Argo Navis was divided into three. And the three constellations we have now, we've got Vela, which was the sails of the ship, Carina, which is the hull or the keel, and Puppis, which was the poop deck, where the people stood and everything. There's actually a fourth constellation that used to belong to Argo Nebula. It's a very small one. It's still up there. It's called Pyxis, which means the maritime compass. So all the things you needed, of course, for a sailing ship, the sails, the hull, the poop deck, and your compass to find your way around. So, and constellations, we should point out, by the way, are just join the dot affairs these days. I mean, in the old days, there were mythological meanings to them, but these days they don't mean anything scientific at all. They just sort of join the dot things. And in fact, according to the International Astronomical Union and the agreement of all the astronomers, the constellation lines and the figures drawn in by joining the dots, they don't really even take any notice of that. Now, constellations for astronomers are just simply an area of sky, a boundary of sky, as if you looked at a map of your country, Australia or the United States, whatever, and you just saw the state boundaries. Beyond Puppis and high overhead in February, when I say beyond Puppis, heading towards the north, you've got the constellation Canis Major. That means the constellation of a large dog. And yes, there is a Canis Minor, the small dog, a little way away, not too far away in the sky. The brightest star in Canis Major is actually the brightest star in our night sky overall, and that's the star Sirius. The brightest star in the other constellation, Canis Minor, is called Procyon, and it's actually the 8th brightest star in the night sky. So there's a lot of bright stars around that sort of area. And if you continue along the Milky Way beyond Canis Major, you finally get to Orion the Hunter. Many people consider it to be the most magnificent constellation in the sky, but Southern Cross might give it a bit of run for the money. And you go further north still through the Milky Way, and you get to the constellations Gemini and Taurus, which for people here in the south, Australia, New Zealand, that kind of thing, are up towards the northern horizon for us. Now, Gemini is really easy to spot because Gemini is the constellation of the twins, and Gemini constellation has two bright stars that are near to each other. They're called Castor and Pollux, and they're really quite easy to see. Taurus is easy to spot too because it has a very obvious wedge-shaped grouping of stars that includes a star cluster called the Hyades. It's really, really pretty. If you've got a nice, clear northern horizon and not too many lights about, you can make out many of these stars in this constellation with your own eyes. But a pair of binoculars, even a small pair of binoculars, reveals lots and lots of them. So it's a really great thing to have a look at. So that's a bit of a tour of the Milky Way. Now, what about the planets? Well, Venus is the star of the show in the evening sky at the moment. You really can't miss it. It's fairly low above the western horizon after sunset. It's the only planet in that part of the sky, and it's big and bright. Venus is even brighter than the star Sirius we were talking about before. Take a look on February the 27th and 28th if you've got clear weather, and you'll see the moon. We're fairly close to Venus, so that should look pretty good in the night sky with the moon there and the bright planet nearby. Mercury, which is the innermost planet, of course, it's not in view really at the moment. I mean, if you really knew where to look and you wanted to go looking for it, you could find it, but it's really too low in the evening twilight glare in the first half of the month, and then it swings around into the morning sky, but it's really too low in the dawn glare getting towards the end of February, so I really wouldn't even bother trying to spot Mercury at the moment. But the other main planets, Mars, Jupiter, and Saturn, now these are really good at the moment. They can all be found in a row in the sky, sort of one after the other, in the eastern half of the sky before dawn. So, after midnight, give it 2 o'clock onwards, basically, you'll be able to see all these three planets all in a row, all strung out in a line, and slowly they'll appear to come closer to each other as the days go past, as the month goes on. And have a look from February the 18th to the 21st, right? Because the moon will join them too. As the moon's going around in the sky, it sort of moves from one spot to the other from night to night. And between the 18th and the 21st, you'll see the moon pass by each of these planets in turn, which is going to be really specky to see. And so if you get a chance to see that, if you're an early riser or you're a real night owl and you're up after midnight, check out those three planets in the morning sky.
Or if you're just staggering home from a night out.
I haven't staggered home from a night out for a very long time, Stuart.
Oh, you poor thing.
Yeah.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram. On Facebook, just go to www.facebook.com/SpacetimeWithStuartGary, with Stuart Gary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.